This is the tutorial for Chapter 5, Section 1, titled Solving Equations, or Solving Systems of Linear Equations by Graphing. It's the first day. So let's take a look at our first problem here. It says your family starts a bed and breakfast. It spends $500 fixing up a bedroom to rent. The cost for food and utilities is $10 per night. So what a system is we're going to end up dealing with two different equations, and this is our first equation that we're dealing with. And so notice that this is a fixed cost. This is an initial value. So what we're trying to do is write an equation in this form. Y equals mx plus b, where b is our beginning value, and where I'm beginning is the initial cost of fixing up the bedroom. And then m is our rate of change. And so our rate of change deals with dollars per night. And so that's going to end up being our slope. And so whenever we're looking at the slope, if we look at the two different variables we have, and the variables that we have are dollars and the number of nights somebody spends at the bed and breakfast, then that tells us that the dollars per night would end up being our slope. So we're going to write that as y equals m, which is our $10 per night, times the number of nights plus the $500. That is our cost equation. And then we're going to have another equation, and that's this one here. Your family charges $60 per night. See how that's dollars per night again? That's a rate of change. And so y represents the cost. X represents the number of nights. That's what the slope is. So notice that this slope is $60 per night. And so remember, when we were talking about slope was the change of y over change of x. So I know y represents the dollars. The nights, the number of nights, represents the x values. So that's going to be y equals 60x. No initial charge here because you're not starting with any money. You're just charging that $60 every night. And so this is called our revenue equation. Another word for revenue is income, the amount that you earn. And so we're going to see when these two end up making or having the same value. And that's what we're going to look for. And that's going to be called our break-even point. And so that's what we're going to end up looking for in this problem. So our first step was to figure out the two equations so that we could go ahead and fill in our cost equation, our revenue equation. So now what we're going to do is we're going to substitute some numbers in for x, for the cost equation. So remember, the cost equation was that 10x plus 500. That was what that was. So we're plugging in 0 for x and then multiplying it by 10, adding 500. So you see how you just get the 500. And then after one night, you have to multiply 10 times 1, and that makes 10 plus 500 makes 510. And so you can see after 2 nights, it's going to be 520, 530, 540, and so on. So you just keep on filling in the chart all the way across. And then once we're done with that, we'll move on to the revenue equation. So taking a look at the revenue equation, we've got a amount that's 60x. So I've got one more to fill in here, $610 after 11 nights. And so my revenue equation, I have to substitute 0 in for x, multiply by 60, and I get 0. So you see, after 0 nights, you can see how we owe $500. But then after the first night, we have made $60, so that's what our customer gives us. But we still have costs. We have that $500, that initial cost, plus the extra $10 for the utilities and the food. But now we've made some money. So you can see how now the numbers are getting closer together. Before we were 500 apart, and now we're less. If we subtract those two numbers, we're only $450 apart. And so now we go ahead and add another night and add another $60 to that $60, and that makes $120. And so we'll continue going, and you see how these numbers are getting closer together. And so this is going to be $2,400 on the fourth night. 5 times 6 makes 30, so that's 300. 6 and 6 make 36, so that's 360. 6 and 7 make 42, so that's 420, and then 48, so 480. And then 54, so 540, and look how close we are. This was 590, but now we're only $50 apart. And so the next night there, we're going to end up being the same amount. And so here we've got $600. 6 times 10, or 60 times 10 makes 600. And then after that, the 11th night is going to be 660. So you see how the revenue, the income, is higher after the 10th day. But what the 10th day is a special day, because that's when we end up having the same amount. See, before we were always in debt. We were in debt 9 days there until we got to the 10th day, and then we were finally out of debt. We broke even, we say. So how many nights does the family need to rent the room before breaking even? Or in this case here, the cost equals the revenue. That's what the breaking even is 10 nights. So 10 nights, the cost and revenue equal $600, the same amount. And then after that, we're starting to make money, so that's the good thing. See how we've made $50 now. $660 is what we have in revenue, but our costs are $610, so we're actually in the black now. We have made some money. So now we're going to see what that looks like on this graph. And so here we've got an XY coordinate plane, and the x-axis represents the number of nights. And then our y-axis represents the amount of money, the dollars that we've earned. So we'll just say amount of money. So what we'll do is we'll start off with our first equation, our cost equation. So notice how the y-intercept was at 500. That's our beginning value. That's where we started. We started at $500, and then we ended up spending $10 every night. So on this one, it's going up by 50s, you can see. So there's one space in between, so we're going by 50s. So I can't really get a point in there until I get over to 5 nights, because then I'm up $50. So at 5 nights, I'm at $550. Well, at 10 nights, we were up at $600. And so then we've got enough points to be able to draw a line through. So we'll do that. So that's a straight line right through those points. Good to use a ruler as you're doing that. And now we'll go ahead and take a look at our revenue equation. I'm going to go ahead and write down this is our cost equation here. Our revenue equation is y equals 60x. So we started here at 0. And then the first point I can really use is this one right here, 5, 300. So 5 nights, $300. So 5 nights, I go over to 5, and then up at $300. That's what the equation gave me. And then over here at 10 nights, we are at $600. So over to 10, up at 600, and that's where the two lines are going to end up crossing. So you can see when I go ahead and draw this line in there, at this point is the point of intersection. And again, that's our revenue equation. And that point of intersection, again, is a big point because that's when we broke even. So that's the break-even point. So that's what we're going to be looking for as we solve these systems of equations. The systems mean we're solving two equations on the same coordinate plane, and we're looking for where the two lines cross. And again, that point is at 10, 600. And the 10 means something. It means something if we have a problem like this where x, we know what x is. X is the number of nights, 10 nights, and then y is the number of dollars, $600. And so we're going to see some other problems like that we're going to graph, and we're looking for this point. And this point is going to be our answer to the problems. So let's take a look at a few other types that we'll end up seeing today. And here it just says to solve the systems of linear equations by graphing. And the slope-intercept form is going to be a great method here. So this is our y-intercept. So I'm starting down one space on the y-axis, putting the dot right there, and then looking at the slope. The slope is the number in front of x. So I don't see a number, so I treat it as 1 over 1. So I'm just going up 1 and over 1 each time. And I also go the other way as well. So I go down to the left, and that'll get me some extra points on that line. So now let's take a look at the other equation. And the other equation is y equals negative x plus 3. So I'm going to start at the positive 3, put the dot right there, and then use the slope. So notice this time I've got that negative sign in front of x. That means it's a negative 1 over 1. And that's the same thing as saying 1 over negative 1. So that means I'm going to go down and then to the left. Down to the left. And you see that's where they cross. And that's what I'm looking for. So just as the break-even point was where the two lines crossed, well, that's what this solution is as well. So our answer to this problem is going to be this point right here, which is 2 spaces to the right, 1 space up. So I write 2, 1. Put some parentheses around it to show that it's an ordered pair. So let's take a look at another problem, and it shows where we've got quite a big y-intercept, and I'm not going to be able to fit it if I have a one-to-one graph. So sometimes you have to modify it. And so I'm going to go ahead and modify this. I'm going to count by 2's. So this is 4. This is going to end up being 2, 4, 6. This is going to be 8. This is 10. Now, I have to get up to 14, so I can see that I'm going to have to go up a couple extra spaces. So I got to extend my graph a little bit more. So this is going to be 12 up here, and that should be enough. You see, I'm going to start up at 14, this point right here, and then follow the slope. The slope is negative 5 to 1. So let me rewrite that. So negative 5 to 1. And so I'm going to go down 5 spaces, down 1. Now, if I go down 1 space, that's actually 2. So this is 2. This was at 14 right here. 2, 4, 5 is right in the middle, and then over 1 is going to put me right here. So I started here, and I went down to this point. And I do that again. So this is 1, 2, 3, 4, 5. So now I'm right on the line, but then I go over 1, puts me right here. And again, I'm going by 2's here as well. So this is going to be 2, 4, 6, 8, and so on. And so I'll do that another time. So I go down 2, 4, 5 is going to put me right here, and then over 1. And then do that one more time. I go down 2. This is 1 actually. 1, 2, 3, 4, 5 over 1. So there's as many points as I can fit on this line. And I'll go ahead and draw the line between those points, being careful to, and I go on those points best I can. Okay, and it's real important to make sure that you have those points on there. And then again, if you're using the ruler, it makes the line a lot straighter and easier to see. So let's take a look at the next line, and it says y equals x minus 10. So I got to start down 10 spaces. Now I can fit that on this line. It's going to start right there. And then the slope is 1 to 1. So I'm looking at this number in front of x, and it's just 1. So it's 1 over 1. So I'm going up 1, and then over 1, up 1, over 1. Remember, I'm using 2 spaces as, or 1 space is 2. So just up a half space is 1. Over a half is 1. And you can see how this is where they're going to end up crossing. So you can see how this line is going up at an angle like this. And I'm looking for where the lines cross at this point. And that's going to be my answer there. So I'll highlight that in red. And when I'm coming up with that point, remember now we've changed our coordinates. So this is 2, 4, so it's 4 spaces over, and then 2, 4, 6 spaces down. So that's 4, comma, negative 6 for that point. So let's take a look at the last type of problem here, and this one shows y equals x. No number out here, so that means our y-intercept is 0. So I'm starting at 0 and then using the slope. The slope of this line is 1. So that's my slope. This was my y-intercept. So I'm just going up 1 over 1 each time. And just getting a bunch of points on this graph so that I can figure out where they end up crossing. So it's hopefully going to cross right at one of these points. And I'll draw the line between them. And then we'll take a look at the next line. So the next line is y equals 2x plus 1. So this is my y-intercept right there. So I go up 1 space and I follow the slope. The slope says 2 to 1. So 2 to 1 means that I'm going to go up 2 over 1 space. Now notice how I'm not getting closer to the line as I go up. And I'm actually getting further apart, so we have to be able to go the other way as well. So down 2 left gets you on that same line, and look, they cross right there. So down 2 over 1, down 2 over 1, so you can see the line a little better. So we see that they cross at this point here, and I'll highlight that again in red to show you a little bit more. Right there's where they're crossing. 1 space to the left, 1 space down, so that point is negative 1, comma, negative 1. So those are the types of problems that you're going to end up seeing on tonight's homework. Let's take a look at a review type problem real quick. So on this problem, we're going to go ahead and solve it by combining some like terms. So I'm collecting the like terms right here, and when I combine them, I have to line up the decimal points. And so I end up with a 2 3/10 x. Now this 5 4/10 I'm going to add to the other side. And so I have to line up the decimal points again. Notice how they're opposite signs, so I have to subtract. So I'm going to end up having to borrow. And so this is going to change to a 9. And 9 minus 5 gives me 4 and 6/10. So 10 minus 4 made 6 tenths. And so I divide by 2 and 3 tenths from both sides, and I move the decimal point over one space to do that division. Set it up. 23 into 46 goes 2 times evenly. So that would be my answer. X is 2. And so the next problem, I've got some fractions to combine, and so when I combine it, 2/3 and 1/3, since they both have h here, I can collect those. That makes 3/3 h, which is the same thing as just 1h. And so I have that plus 11 I'll bring down and equals 8. So I'm subtracting the 11 from all sides and isolating the variable h. And once I do that, I get the answer. H is -3. So those are the types of problems that you're going to see on tonight's homework. Good luck.